Welcome to Organic Chemistry tutorial. This is Dr.L.Emmanuel from Department of Chemistry, Carnegie University. Today I am going to solve a problem on hetero diels alder reaction. You can find this problem in CSIR NET exam 2015 December. Here is the problem. When this diene is treated with this alpha keto ester methyl pyruvate in THF followed by treating with trifluoroacetic acid, what is the product? From the given options, it is very clear that it undergoes 4+2 cycloaddition. Since this oxygen is from pyruvate, it is hetero diels alder reaction. You can see here these two look similar, CO2Me, CO2Me, but they are regioisomer. The keto group, it acts as electrophile and it has added here. In second and fourth, again they are regioisomer, but in this the ester carbonyl has been added to the diene. Now, which one of this is facile? First, let us see what is hetero diels alder reaction. A diene in the cis-oid conformation reacts with carbon and heteroatom double bond to give a cyclized product. So this is hetero diels alder. The hetero refers to the heteroatom in the ring. In our case, the diene, it is not cis-oid. The given compound, it is silyl enol ether. So this is not cis-oid. Cis-oid is the conformation in which both the alkenes, they are facing the same direction. You can see this. Both the alkenes, they are facing the same direction, but here they are facing in opposite direction, but it can be rotated through this carbon-carbon single bond to give the cis-oid conformer. Since it is trans here, I have written trans O TMS. TMS, that is nothing but trimethyl silyl ether. Now, if I add pyruvate to this, there are two carbonyl groups. In this, which one will act as electrophile? This or this? You may know that ketone carbonyl is more electropositive than ester carbonyl. So this can be easily attacked by an electrophile, an nucleophile. So this carbonyl group undergoes diels alder reaction, not the ester group. Now the question is the regioselectivity, whether the oxygen will add to this carbon or this carbon. So that is regiochemistry. To explain that, I go for this mechanism. Even though diels alder reaction, it is concerted mechanism. I give this arrow shooting mechanism. Here, since it is silyl enol ether, this lone pair of electron can go here and it can attack this one. Also, I can go for this lone pair of electron. This also may come inside. Then it can attack. Because of this carbon, it is highly rich in electron. So this acts as nucleophile. Here, since it is beta alpha ketoester, because of this electron withdrawing group, this gets more del plus. So this nucleophilic position attacks here to give now this we get the cyclized product. Basically it is concerted mechanism, but for understanding I have given this arrow shooting mechanism. When I treat this with TFA, that is trifluoroacetic acid, trifluoroacetic acid cleaves this bond. As a result, this is getting eliminated to give the product. So the product, whatever we get, will be like this. Here there is a double bond. OMe is the leaving group. There is oxygen. So this is the product, whatever we get in this hetero diels alder reaction. If you look at this, the substituents are in 1 and 3rd position. But in diels alder reaction, you may know that 1, 2 and 1, 4 product are more favored than 1, 3. If you go for concerted mechanism, you may wrongly predict the substituents here. That option also has been given. So you may predict the other regioisomer. If you go for this mechanism, then you can predict the product correctly. One more thing to note in this mechanism is this particular moiety. This moiety is known as push-pull alkene. That means this OMe, since it is electron donating, it pushes the electron to the carbonyl. Since the carbonyl, it is electron withdrawing, it is pulling the electron from the double bond. So that is why we call it push-pull alkene. One more thing, once it is hydrolyzed using trifluoroacetic acid, what we get is O minus. It gives enolate or enol form. Then the enol form eliminates OMe. OMe acts as leaving group. Generally, OMe is not a good leaving group. Halogens, triplet, mesylate, acetate, they can act as leaving group. But when it is in the beta position to electron withdrawing group, and when anion is at the alpha position, then there is possibility for elimination. Now let us go to the given options. First and third, already mentioned, they are regioisomers, CO2Me, here also CO2Me. That means the ketocarbonyl group has undergone 4 plus 2 cycloaddition. In this case, the ester carbonyl has undergone 4 plus 2 cycloaddition. This is not possible. This also not possible. In this, which regioisomer? As per mechanism, whatever we have got is this one, not this. Thank you for watching. Have a nice day.